keep solving our physics subject GRE. So 68. Basically, what it asks is you have set this element into this element, and ask about what is the possible radiative reaction. Okay, so you see, there's the change is just this 4 go to 3. So the possible ways is the image capture electron, right? Once you capture electron, then you will this from 4 to -1, it gets 3. And then once you have, every time you capture the electrons, then the lepton number need to be conserved. So you must capture capture anti-neutrino or emission neutrino. So the answer is E. And you can check A, B, C, D is all impossible. For example, A said that it's emitting an alpha particle only. Alpha particle is the helium atom. So if you emit the alpha particle, then 7 should -4, which is impossible. So you can use this way to check that others are also impossible. Okay, so 69 is a thin film. Basically, you have blue light wavelength 400 nanometers. It's mostly reflective thin films of all your glass light when you near normal. Assume the index of refraction of oil. So N is 1.2 for oil, and for the glass is 1.6. Then the one is the thickness. Okay, so the wave will come in and out. So the light path difference is 2t, right? Suppose this is t, then the thickness is 2t. 2t is basically lambda. So the lambda can be solved like let me see. Oil on a glass slide whose view near normal surface. Okay, so the T, this is 480. So T can be solved close to 200 nanometers, 240 nanometers. Okay, so basically that's it. It does not depend on this N, right? Because so the answer is close to B, 200 nanometers. Okay, so 70. A light from laser photon pair of very narrowly separates 0.5 micrometers, and bright fringe separate by 1 millimeters on surface distance screen. If the frequency of laser double, then what is the possible separation? So the single slit have this m lambda close to d is d sine theta, so which is close to d theta if sine theta is small. Okay, and also you have this lambda just your speed of light, just lambda times frequency. So you have this c over frequency close to d times theta. Okay, so frequency doubled. You see frequency double, right? Theta will be half of it. Okay, so the answer is B. D theta will have half of it. So I should write d theta. Okay, so the answer is half of 1.0 millimeters. So it's 0.5 millimeters. Okay, 71. The ultraviolet level alpha of the hydrogen has 121 nanometers is emitted by an astronomical object, and observer on Earth measures the wavelength of light received from the object to be 600.75 nanometers. Then observer can conclude the object is moving. Okay, so this is the standard Doppler effect of light. So we have lambda divided by lambda naught is square root of 1 plus beta divided by 1 minus beta. So this is 6, close to 6. Then we can solve beta. We get this one. So beta is v over c. So we get the velocity is 35 over 37 c, which is close to the choice D. Okay, so we can just the direct computation. Nothing special. So 72 basically. You have identical blocks and connected by a spring. The combination is suspended. At rest, the front string attached to the ceiling, as shown in the figure above. The string breaks suddenly. So connected by a string, right? The string breaks suddenly immediately after the string breaks. What is the downward acceleration of the upper block? Okay, so you have this. Okay, so in the originally there's a kx force, right? So in originally this one has kx equal to m and g, and this one has t, right? So t equals to kx plus mg. This is for the upper one. This is for lower one. Okay. And when so for the middle one, if the middle one string breaks suddenly, then what you ask about the downward acceleration of the upper blocks. So basically this one. Okay. So after the string is cut, right, the tension is zero. So string cut, t is 0. So what is the force from downward? The kx plus mg, right? But also k is equal to mg. So the force immediately is 2mg equals to ma. So m is 2g downward, right? Because in this upper you have t and you have mg, you also have this kx. But when the tension is broken, then what you get is mg plus kx. So the answer is 2g. Okay, 73. You have system AB and the mass of AB is 60.0 kilograms and 4 kilograms respectively. Horizontal surface frictionness, and then there's a coefficient of frictionness between two blocks at 0.5 and magnitude f most nearly. Okay, so the total acceleration is f divided by 20, and the force act on this B. Okay, then you just ma, right? So it's f divided by 5, just times 4, and then you have this mg. Okay, and this m is basically 4g. M is 4. So in order to that, so this is friction. The friction must be 4g, and the friction is 0.515 or 0.5. Sorry, not 0.15. 0.5 times the support force. So the support force is this force now. Divided by 5 is 4g. Okay, so we can solve this f. Okay, so the same easy computations, which give you the answer. The answer is 400. Yeah, right. It's 5 divided by 0.5 is 0.1. So this is 400 Newton. Okay, so I think it's enough for today, and I will see you guys in the next video.